Hey everyone, it's one of my favorite days. It's a Pancake Breakfast Day. And today, sponsored by Accurics, we have a discussion about immutable security. Immutable infrastructure goes with immutable security, and it's hot. So let me just get the guests right on, and then I think we're going to have a little something to eat here. So first off, I want to introduce Om Moolchandani, CTO of Accurics. Hello, Om. How are you?
Hey, can you hear me?
Certainly can.
I'm doing great. Absolutely. Thank you for having me.
I like the apron. You're the first Pancake Breakfast attendee to come with an apron, and I am impressed.
Not only apron, my pancakes are going to get live whipping cream as well.
Oh, look at that. Man, I'm loving this. Next up, we have Rosemary Wang, developer advocate at HashiCorp. Rosemary, hello.
Hello.
And welcome to our Pancake Breakfast. I hope you have a little something there.
I do. I have my giant spatula.
Got a spatula?
Which I use to make my lovely pancakes, but we're going plain today, just maple syrup.
Perfect. And up next is Krishna Bhagavathula, CTO for the NBA.
Hi there. How are you?
Good. How are you, Krishna? Nice to see you here.
Likewise, I got some, pumpkin spice maple syrup from Vermont. And I also have a spatula. If you guys can see this is an LA Lakers spatula for obvious reasons.
Ah, yes, the Lakers. Well, we're wondering if LeBron is a pancake fan, and our guess is yes. And Chenxi Wang, managing general partner, Rain Capital. Chenci, great to see you again.
Hi, how are you, Alex? I've got my coffee and I've got my syrup. It's prickly pear syrup. So be careful what you say. I may pick you.
I like it. And Priyanka Sharma, general manager of the Cloud Native Computing Foundation. Hello, Priyanka.
Hello, everyone. Very nice to see you at KubeCon, Cloud Native Con, North America. And I have with me maple syrup as well, because I am a very big, like pancakes are not pancakes without it. And also some additional topping. Oops, sorry, I'm going the wrong. Bon Marche Maman, orange marmalade. I'm a big fan of this brand. Oh, I'm ending up, now I'm promoting it. Oh, well. Highly recommend. This is just orange, but their strawberry is what I love the most.
So you have the CERN collider behind you. Are you having particle pancakes this morning or today?
That's a good one. Particle pancakes. Well, so CERN does a ton of work with cloud native technologies, and they've keynoted in past KubeCons, etc. So whenever I have a call with them, I turn on this virtual background and feel inspired, like I'm in the middle of science. Right now, it's because I recently had a call with them.
Well, Krishna, I don't think Rosemary has any syrup. Do you want to pass the syrup up to Rosemary? Give her try the. Oh, there you go. Oh, perfect. Okay. Hey, can you pass me? Or maybe. Well, who has some syrup there? Some whipped cream? Oh,
I've got some syrup, but that's kind of maple again. So there's a lot of maple that we have.
Well, thank you very much. I think it was one of those particle physics things where it went from whipped cream to maple syrup. How about that? Talk about the live effects here. So anyone else have anything that they have to share with us? Is there any butter? Does anyone have any butter?
I believe so. Yeah, I've got some butter.
Okay, thanks. Just pass it over and pop it in. Okay, it's on the table over there. I'm going to take a try of my pancakes here, and then we'll just get started. Anyone else?
I can't believe it's butter.
I'm going to put these aside for later. I brought my spatula too, but let's just get started. Our topic today is immutable security. Immutable security is an interesting topic for us over here at the New Stack. It goes into kind of the where we are today, I think, in the continuing life of cloud native technologies. And we would not have been talking about security very much a few years ago. That was on people's mind. I'm sure it was on the people's mind who was actually thinking about putting this in production. But today it's a little bit of a different story. And I wanted to share something from Ph.D. Sharma, who's the Accurics co-founder and chief product officer. It might give us some context here. And again, I just want to thank Accurics for sponsoring this Pancake Breakfast at KubeCon. And here, let me read it for you. As organizations rapidly adopt new technologies such as serverless, containers, and service mesh, cloud infrastructure is becoming increasingly immutable. Infrastructure is never modified after it is deployed. If something needs to be modified in any way, new infrastructure has to be provisioned through code. Securing immutable infrastructure requires a fundamentally new approach where infrastructure configurations must be managed for risk through code. Risk through code, that's an interesting topic. Unfortunately, most organizations do allow changes to infrastructure configurations in runtime, which breaks immutability. Accurics enables immutable security by programmatically detecting and resolving risks across infrastructure as code before infrastructure is provisioned, and maintains the posture in runtime by programmatically mitigating risks through IAC. So I want to maybe just go right to you, Om, and just talk about this concept a little bit. And for people out there, we're really seeing much more attack surfaces open up, and that will just only increase as immutable immutable infrastructure becomes more widespread. My question is, what role do these concepts play, inside end user environments right now, and who's responsible? Who has what roles? What are the personas that they play? What is that developer experience that really is required so things don't get lost and troubles arise?
Right. I mean, Alex, fundamentally, what are we observing today, in terms of immutable infrastructure out there, is that even immutable infrastructure is being built in layers, right? So if you are today trying to, deploy a traditional cloud native architecture, say on a public cloud environment, right, you would see a few layers going into it. You will see a cloud layer. On top of it, you will see Kubernetes layer. And then on top of it, you could see another layer, which can be a service mesh layer using Linkerd, or even serverless layer on top of it. So you have multiple layers now in your cloud native infrastructure. And all these layers now, are coming with immutability built into them as design. So what does immutability in this context, means? Well, fundamentally, what it means is that there is going to be single source of truth when it comes to change management, right? And the strategies like rip and replace are going to take over. And instead of people making changes directly into your runtime environment, they'll be making changes using the single source of truth. And that could be anything, but that also could be infrastructure as code. So now when the infrastructures are being developed and deployed, there are multiple teams here, multiple roles here, which are working together. So you have your traditional DevOps team, which is converging more and more towards, development. They are writing active code now in terms of infrastructure as code to define, as well as to, declaratively, mention all the configuration settings in code and codify the cloud representation or the cloud native infrastructure representations. So you have DevOps teams on one side developing code, and then you have ops teams deploying it. And then you have, of course, the security teams who are responsible in some way or shape to deliver security for this architecture, not just in the development time, but also during the runtime. So these are the predominant three different personas which are playing the game in tandem with each other because of the immutable infrastructures that have emerged.
Do you buy this, Chenci?
I was going to say, let's hope there's one single source of truth. Because with infrastructure as code, I think we can get there. There's the instrument is there, but what you see in real production environment, even if you have Terraform, you have Kubernetes or Chef and Puppet, what you get is you've got this developer is Docker exec into the container in runtime and change things and nobody knows about. So immutable infrastructure, immutable production environment is a great concept, but let's make it happen in a way that's manageable and all of us security operations can benefit from it.
So Krishna, when you're thinking about this, you think about security at step 7 of 10, 4 of 10, 6 of 10, 2 of 10,
Now,
9 of 10.
Great question. The one thing I'll say, right, is I think this nirvana or this pursuit of immutability, right, has been around for a while. I'm an old guy, right? If some of you have worked in Java environments, you know that back in the day when we were deploying web archives or WAR files, the intent was that's an immutable WAR file that goes across multiple environments, right? That's not the case. You and I know that. So I think we've at least in my group we have that in our mind, right? We know that that's what we want to achieve, and we are shifting our priorities as we think about developing applications. There's this huge mindset shift, right? I mean, people talk about the shift left mindset, and we have adopted that. But I'm not saying that we have solved all the problems. I'm just saying that yes, security is definitely a first-class citizen, or at least attempting to be. It's no longer a seventh class or step 7 citizen, at least in environments that I've been working in for the last 3 to 4 years. So that's certainly changed.
Rosemary, you work in the world of HashiCorp, which is becoming a software powerhouse in itself, and you must be thinking all the time about these types of issues. I mean, you don't have to run the HashiCorp infrastructure, but you guys are making software. From your perspective, where does security sit? And is it and Terraform is so well known as an infrastructure as code environment, but there's also so much policy that we need to think about as well.
I think that it is something that's easier to do. We're making tools that make it easier to communicate the intent of what we're looking for, right? I think security is not necessarily fully difficult because of a technical constraint. It's kind of a constraint of communication. You don't know what you don't know. I think even when I wasn't necessarily using HashiCorp tools, as someone who was a systems engineer, I didn't really know what was the consequence of, let's say, exposing an S3 bucket with metadata. And policy is one of the ways that you communicate and you teach proper infrastructure as code, and by extension, immutability. I think that it's a really great way to communicate what your organization is looking for across anybody who's doing infrastructure as code.
Priyanka, what's all this talk about open policy agent? I keep hearing this come up quite a bit. What's going on over there? Well, why is this gaining such popularity as a project?
Yes, well, at the end of the day, it's about the market size. Right now, everyone we've talked to, right? We have NBA over here. We have HashiCorp over here. Everyone is telling us how people need to understand what's going on, what counts as good security. And as Rosemary said very eloquently, things like OPA or OPA are able to teach that to the rank and file developers, the rank and file admin person, all in one go. Like the same information is seen propagated across different parts of an organization. And I think that is huge. That is why things like OPA are becoming so successful. It's solving a real need. And I mean, it's one of the very highly used projects in the CNCF. There's new stuff coming out all the time. Just, I think it was today that they had an Envoy integration that came out, which is awesome because Envoy as the reverse proxy sits at the core of so much stuff and can propagate all this OPA policies to different parts of the system, to different people. So lots of movement, lots of growth and usage. Why? Because it's a real problem. Everybody needs to be on the same page. And OPA is one step towards a single source of truth.
Well, go ahead, Chenci. You have any thoughts?
I want to add one thing. Alex, you and I have been talking about this sort of in this space for a long time, right? We met, 2015 in a coffee shop in San Francisco. And I was pitching to you the idea of immutable security back in 2015, right? And so are we here yet? We're not quite here yet, but we're making progress. I think OPA is one step towards the right direction. And as I'm a security person, I've been in security for a long time. You cannot deliver assurance if you cannot measure something. And you cannot measure something that you cannot specify. So I think OPA and others that giving a static way of describing and stipulating the production environment is exactly what we need for immutable security to happen.
We're getting somewhere, I think. Now, that brings up some other topics. I have in the back of my mind this idea of comparisons that can be made here, Om. And when you're thinking about that, and then I want to touch on remediation as a code, which is another phrase that you're throwing at us, from Accurics, and I need to get my head around this. But let's talk about these comparisons first, because you can't. I was thinking about this on a walk yesterday after we had a bit of a chat, and I was thinking, what really can you do without any comparison? You can't really do anything. And so I think one of the things that I find, at least in our world, is we hop from topic to topic to topic, and then you start talking to technologists and they're saying, then we also have to think about this project. We have to think about this. So context and comparison is always there. So when we're thinking about immutable security, what is that context? What is that comparison that needs to be made when you're thinking about infrastructure as code, when you're thinking about OPA, when you're thinking of other issues that come up when you're running very complicated microservices in production?
Yeah, so, OPA is one of the, backbone, I would say, technologies that, we also use at Accurics. And it's really revolutionary, the way OPA was designed and how it is helping. Now, we were one of the first ones to adopt it. But here's the thing about comparison that you are, alluding to. So imagine that you are trying to deploy a multi-layer cloud-native infrastructure. You are using Terraform for deploying your cloud infrastructure, your compute network storage, and then you are using your, say, Helm charts to deploy your Kubernetes clusters, and then we are using OpenFast YAML to deploy, more microservices on top of it. Now, all these three different infrastructure as code technologies, if you're using that, right, just imagine they are so much polyglot in nature. They are different, but you are using all three of them to deploy the same cluster or the same cloud-native infrastructure on top of it, you will run your applications. Now, what OPA does here is that it opens up the doors for comparisons. So just imagine all your declarative configurations are defined in this rich infrastructure as code. Your Terraform, your Helm chart, your OpenFast YAML files, they've got all the definitions for all the resources that you would have deployed. Now, that's your, single source of truth if that adoption is kind of moving forward. And then you use OPA to bring all these polyglot infrastructure as code technologies together, apply the policies for comparisons. So OPA can basically allow you to do these comparisons in a very, very seamless way. I believe it's a de facto standard today in industry to do policy as code. Of course, it was designed for a purpose to do certain kind of, admission controller-based use cases. But we've taken OPA to next level in our product. We use it to make comparisons with Terraform, with Helm charts, with customized templates, with CFD, with many other infrastructure as code technologies. So that's what is your comparison piece. But what is also important in the immutability space, the security problems that you're facing are going to be majorly what Chenxi was alluding to of drifts. So it's not just going to be the security-based policy as code use cases, but you see when the developers, DevOps teams, ops teams, when they're going to address break the glass situations or emergency situations, they're going to go and make direct changes into your clusters, into your cloud environments. You need to be able to also make comparisons of those changes that are happening, identify those drifts, and then address them. Those drifts can be very, very dangerous. A lot of breaches have happened because of the drifts that have been caused between infrastructure as code and cloud, and also between your previous versions of your cloud native architecture and the latest version of it. So that's how comparison works. Yeah.
Rosemary, aren't we talking about GitOps here? Doesn't this kind of, it sounds like GitOps, like, you can just roll it back and, so you can keep reaching that desired state. Is that remediation as code then? Is it really just GitOps?
I think it is, but I also think it's not just a roll back. It's constantly rolling forward. That's the intent behind immutability in the first place. You're never reverting back to a previous state. You're just overriding state constantly. So I think that remediation at its core is very much about, let's roll forward. Let's make changes that override a previous state so that we can actually secure something, or we can get to a desired state. So it's really fascinating, I think, about measuring drift, or even sort of the idea of security architecture, is that there's a deviation from how far you expect your security to be, and then the actual security of your infrastructure or any kind of application that you're running. So measuring that and closing the drift is really a really core part of continuously measuring that. And that's the part of remediation that is often missed. It's continuous.
Yeah, just a quick thought, Alex, on that, if I can just add to that, what Rosemary said. I mean, look at the emerging projects that are coming up. I mean, the Sandbox project in CNCF today, which is Flux CD, right? In my opinion, these are the kind of technologies which are going to enable a lot of remediation as code based implementations. These technologies, which are, I like to call them, they are self-clustered continuous deployment projects, which allow you to continuously do GitOps by remaining within the cluster itself. No need to manage separate infrastructure for your GitOps deployments or operations. I think these are the technologies which are sitting as gatekeepers for immutability to be maintained, because they pull all the infrastructure as code and automatically deploy your clusters. I envision that these technologies will receive security capabilities also to identify the security gaps using policy as code and do inline remediation as well. I mean, once that maturity level is achieved, I see that these technologies will evolve into hub for doing remediation as code and self-healing.
I hope you folks are considering contributing to Flux and Argo and all great projects, because your vision is awesome and you're absolutely right. That's the direction the wave is going towards.
The day it got Sandbox, my eyes were popping up like, my God, this is something that I can just pull in.
Perfect. I mean, and that's so great for a Sandbox project, right? Because they come in with basically just a neutral IP zone and a space where people can trust and collaborate. And that's exactly what you proved out right there, where you're like, you saw it and you're like, yeah, I can pull this in. So that's great news.
Krishna, I think we're on the same team here, because, you got to be a little skeptical of all this, talk of trust and happiness and immutability. I mean, you talked about Nirvana earlier. I mean, really, what's the reality here about remediation and, and all these kind of like lofty concepts that we have streaming around here?
Well, I'll just say that, I think in today's landscape, right, there's certainly a lot of preventive or reactive techniques to secure our infrastructure. but we certainly need more proactive measures, and that's why I think remediation of code is really interesting. I think the containerization, microservices, they've all given us the ability to package and deploy at scale, right? And we, like many others, like I mentioned earlier, right, we've embraced this shift to cloud native environments. Actually, in the midst of the pandemic, just to sort of set a little bit broader context, right, we in April of this year, we announced a large partnership with Microsoft to essentially create a direct-to-consumer platform that will deliver essentially a new way for our fans to engage with our content. And we are on that journey right now. We want to build a completely from the ground up, innovative direct-to-consumer platform in the cloud that will actually deliver personalized game broadcasts and other content offerings, integrating various products and services across our businesses to our fans. We are calling it the Next Gen platform for now, inventive name. But as we look at doing this, right, clearly, our cloud app footprint, or the number of pancakes that are cooking, is going to grow exponentially, and we want to make sure it's secure. So I also thought it was interesting. I think one of you mentioned a break the glass approach to your deployments. When that happens, right, I think we need policies that are closely aligned with our architecture. That's why I find this concept that some of you mentioned earlier, of immutable security for immutable architectures. I think that's interesting. And that's the approach, along with remediation, that I believe is the approach that will set us up for the future.
Chenci, you live in a world where you're looking at security issues all the time. You have a deep background as an academic in security. You have been investing in security companies. You're a practice technologist. When you think about the complexity of microservices, and we talked about the layers of microservices, and sometimes you can have microservices at their most complex as multiple layers. And so then you have a degree of complexity and chaos that is unprecedented, really, for people to manage. So we get into kind of conversations about, well, what can you actually predict? What can you actually foresee? What can you actually understand about your current infrastructure? What do you get from this conversation that speaks to that need to have that breach path prediction, so to speak?
Yeah, so breach path prediction has been a concept fairly popular in the security industry, and I actually think it's a misnomer, even though so it's understandable, you can relate to what that is. But the reason I think it's a misnomer is that there's just never a single path to breach, right? So there are many different paths, and it's all about what you can do when there's are symptoms happening or there are events that are happening. Now, if I may pull back a little bit, I've been in security for a long time, and security technology typically fall into two buckets. One is I call the hygiene. It is about helping everyone, getting your environment to the best state that you can and don't make any mistakes, and then get into production. That's one. The second category is about dealing with threats. It's dealing with unknown and threats. Now, guess what? About maybe 70, 80%, maybe even more than 80% of security breaches are due to not doing the hygiene well. Right? So it's all low-hanging fruit that somebody made a mistake in configuration. Somebody didn't write a piece of code in the way that should be, very easy stuff. I think this immutable infrastructure and infrastructure as code and policy as code really pushes the state of art forward in terms of security hygiene. Now, if we've done that well, then what's left to do is hopefully in production, you have not only smaller attack surface, but you also have a way to continuously monitor. Right, as Rosemary said earlier, that really what you need to do is understand at any given time if your state has sort of drifted from the known good state and then do something about it, do something really fast. So my thinking of, and a lot of modern infrastructure security folks would agree with me, is do your hygiene well, then in production, detect failure fast, fail fast, recover fast. And that's what you need to do. And that's the way to deal with complexity. And when you have all these microservices going on, if you can localize the effect and basically remediate locally and changing these components really fast and without impacting the larger environment, then you win.
Rosemary, when I think about this, I think about the work that HashiCorp does. And one of the things that you mentioned in a conversation I had with you and the rest of the group, we were talking about codifying the cluster and how you may codify relationships. And perhaps you could tell us about, how that fits with the approach that Accurics is taking when you're thinking about remediation as a code, but also these relationships and this fitness that Chenci is discussing.
Yeah, so there's a fantastic concept called evolutionary architecture, not mine. There's even a book on it. And it more broadly addresses this idea that you have expectations of your architecture, whether they be compliance expectations, security expectations, resource expectations, cost expectations even. I think that all of these fit together, and the measurement by which you understand how far you've deviated from that architecture is a fitness function. So both remediation as code and policy as code, and some of the work that Accurics is doing, really addresses this visibility into a fitness function. What are the deviations? How far are we from this expected architecture that we have? It's not to say that it's perfect, and it's not to say, that we have accomplished and achieved this ideal architecture either. It's to demonstrate and make visible the differences between what you expect and what you actually have.
Moving back to the conversation about shifting left, for instance, and when we think about shifting left, and I guess when we talk about expectations as well, we think about these expectations that we all have of ourselves and each other when it comes to immutable security. But what role does shifting left play, and what are the other things that need to be thought of when you're thinking about shifting left? And a lot of what we're talking about here is self-healing, really. And so I'm wondering how the developer experience is intersecting kind of with these concepts.
Look, one of the very important aspects that have to be taken care of whenever shift left strategies are adopted or new products or technologies are pushed in that direction is to ensure that no new processes, or at least the impact on the existing processes for the people who are working on the left, which are mostly the developers and to some extent DevOps folks as well, are not impacted too much. So if there is a strategy which requires existing processes to be changed, that is going to have a direct impact on the velocity of the developers. That means your shift left is going to now require to adopt new ways to do things. That is a big barrier for adopting any kind of shift left strategy or technology. So that's a very important point, that if you are attempting to shift left any outcome that you were achieving previously by being in the middle or being in the right, we need to ensure that that shift is done keeping the current processes in mind. As an example, when we're talking about remediation as code, the remediation as code can be performed in multiple different ways. But if you offer developers methods that do not require any change in the existing process, for example, you generate remediation as code, create a pull request, and assign that to the developer, instead of you as a product, if you have a remediation as code offering, instead of you as a product pressing the button on the code to redeploy the new remediated configuration in the cloud. Allow the developers to take that action and not introduce new processes. Otherwise, you will end up breaking the velocity of developers. Anything that breaks the velocity of developers, that technology, even if it is superior, fails to get adopted. That's first problem. Now, from the self-healing point of view, Look, what has happened is that, developers and DevOps teams are moving at such large speeds that security is just not able to, catch up with them. That's a reality. And as Chenxi mentioned, right, 70% or maybe 80% of the breaches happen. The principal factor behind those breaches is the lack of cyber hygiene, which are basically the low-hanging fruits, your best practices, your benchmarks, which can easily be detected and implemented and can be codified. That is where the self-healing infrastructures and the self-healing technologies are moving towards. They're not there to solve, all the problems that the security can face, but solving all those low-hanging fruits. That's the first target. And of course, infrastructure as code is enabling it. And probably I'll just take a few more seconds to quickly give you some real example how it works, so that we should also be able to understand, going beyond these jargons, what it is. So take, for example, there's a Kubernetes cluster. You have one pod running in a workspace, and then you have another pod running in another workspace or in the namespace. Now, when you have these two pods running, if one pod is interacting, say, with a database service, the other pod is your front end, which is interacting with your web application. Now, if today we were to report, any security detection technology, when it reports that, oh, you have this database connection which is insecure, right? The security teams as well as the developers team, first of all, they're not going to do anything about it. First answer that you might get is, yeah, we know this, but this database is deeply buried in my network. I have many more security controls on top of it, so don't worry about it. But the moment you start showcasing that, well, you have a problem in the database, and you also have a problem in another pod, which is your web application, and these two are talking to each other. So if this gets compromised, your web application gets compromised, your database is directly in line of sight. So when you report these violations, which are still the cyber hygiene related problems, in connection with the relationship that they share, which we are able to extract now from infrastructure as code, even before the cluster is deployed, we can extract such information. That's where you are able to contextualize and make the developers more powerful when you tell them, go and fix this problem now, because there is a security context that you have attached to it, right? Developers like that because they're not security people, right? They don't want to understand security beyond a certain extent. That's where we are helping, or the community is helping developers with self-healing in infrastructure. So relationship identification and what Rosemary was mentioning, right? These are very important aspects, if you want to shift left.
Priyanka, maybe we can go to you, and then I'm going to go to Krishna for a last question.
Sure. Yeah, I just wanted to say that I 100% agree that when you're shifting anything left, you have to care about the person who is on the left side, which is the developer. Suddenly, we are asking so much more of these people, right? They're supposed to have a handle on operations. They're now supposed to understand the security workflows. So there's a lot going on. And I think from that perspective, GitOps has been awesome because they are used to the Git pull request workflow. And so that I absolutely agree with Om is critical, that be where the person on the left is, and it'll just get the job done much faster. And then I think there's also the element of, and this kind of zooms out a little bit from this conversation we've been having about, like, all of you here are wizards, technology wizards who are really deep into these problems, and you know the best way to solve it, and you have the smartest ideas. But the average developer is just starting on this journey. And I think that's where learning and development comes in. From a CNCF and Linux Foundation perspective, we take it very seriously. And so enabling the community is part of our job. So we have a lot of training programs, as folks know, for certified to become Kubernetes admins, to become Kubernetes app devs. And now today, in KubeCon, you're going to see just how, like, certified Kubernetes security folks, and like what they can do and how they can start signing up and get going. And I'm hoping that will be a small help to get each and every developer comfortable, certified on shifting security left.
I'm going to give a round of spatula applause for that one. Way to go.
This is so important for the community.
I consider myself a cook, not a wizard, but I'll take the wizard. But before we go, Krishna, there's a certain wizardry that has to go with identity, isn't there? When you're thinking of Kubernetes, And because now you have identities of all kinds and all kinds of microservices that are emerging, right? So identity is a real tough issue. There's no really identity platform really for Kubernetes. And so I'm curious how you think about identity issues for those applications and those services. The individuals are another matter entirely, but how do you think about, how are you thinking about that when you're going about kind of building what you're trying to do with this new project that you're building out?
A couple of different things, right? The first thing is by gaining visibility into the cloud environment, observing the data flows, just using tools that will actually give us more perspective into data flows, right? The other one is to actually use tools, Accurics being one of them, for posture assessment, keys, assets, infrastructure, and all of that stuff.
Chenci and Rosemary, just quickly, would you call identity and access management a mildly hot issue, a hot issue, or a super hot issue?
Hot.
4 chili stars.
How about you, Rosemary?
I can't add more hots to that. I'm just going to say it's burning. It's burning in the pan. It's not easy, right? And identity is so difficult. Access management is even more difficult. So I can add more hots, but I'm just going to say burning in the pan.
You can just add the new offering that HashiCorp has launched.
I wonder when someone would ask. Yeah, that's partly what Boundary, which is a new open source project that we have. It addresses a certain segment of access management, as well as some of the other offerings. So that's for another day.
Well, you all should check out the live stream we did yesterday, where we looked at 5 projects and demos, and one of them was OPA. And then we had a roundtable discussion, and guess what came up? Boundary. It came up in our talk yesterday. So you all are on a roll. Let's flip some pancakes for HashiCorp. This is good stuff. So I want to just thank you, everyone. Let's give a spatula round of applause. Pancakes. Yay. Thank you so much, everyone, for taking the time. This has been a lot of fun and really enjoy this pancake breakfast. I just want to thank her to go around the horn here. Om, thank you so much for joining us. Om is a CTO at Accurics. Rosemary, developer advocate at HashiCorp. Krishna, CTO of the NBA. My son's a big Carmelo Anthony fan. If we could get a 101 pancake kind of thing going, with that new content platform you're building, that'd be awesome. Chenci is always wonderful to have you on the show. Managing General Partner, Ring Capital, and Priyanka, Particle Pancakes. I think that's it. Way to go. General Manager at CNCF. Thanks everyone for joining us, and we look forward to KubeCon and having a great show. Thank you.
Appreciate it. Thank you.
See you at KubeCon.